Alright, chapter 5.3, finding unknown measures in similar figures. Now we have a couple of similar figures here. This figure is similar to this one. And if we want to find the unknown measure, that's x, we could set up a ratio. And we can do it a couple of ways. We can say this side corresponds to this side, so we could set it up 6 over 9 and let that be equal to 8 over x. Then we can just use cross products. I also could have set it up like this. 6 over 8 is 9 over x. And we should be able to come up with the same answer either way. Well, let's try it and see. So cross products is 9 times 8, which is 72, is equal to 6x. And then you divide by 6. 6 times 10 is 60, which leaves 12, so 6 times 12 is 72. So that works. So x is equal to 12. 12 meters in this case. And let's see if it works for this other option. 7 times 9 is 72. And 6 times x is 6x. We have exactly the same thing. So x is still equal to 12. So you can set it up in a number of different ways and still have it work. Hopefully you can understand that and appreciate that. It makes it kind of nice. So that's that problem. I was gonna try again. Just trying to get rid of all this. I can't quite do it. There we go. Okay, so down here, now that I've done that, maybe I need a little more room. So I'm showing off a little bit. So we're going to move this up here and then put a little line there. Okay, so let's look at this one. This is a little different. They are giving us the ratio of the perimeter, 12 to 5. And they're giving us one side, and the corresponding side is x. We have 15 and x. Notice that this has been flipped over and around, and it's been changed. The position has been changed. But if you look at it carefully, you recognize that this is the long side of a parallelogram, and this is also the long side of a parallelogram. So if these are similar, and we're assuming they are, then this 15 matches with this x. It's the long side. Alright, so we have the ratio is 12 over 5. And I'm guessing that 12 colon 5, I wanted to make sure you saw that you can remember the ratio can be written 12 colon 5 or 12 to 5 or 12 over 5. So 12 over 5, we'll go ahead and write it like a fraction. That's how we're generally going to work with them. The 15 is the big one, x is the small one, so I'm assuming that it's going to be like this. That should make sense to you too. Alright, so 15 times 5 is like 10 times 5 is 50, and 5 times 5 is 25. So we get 75. So 15 times 5 is 75. So our first cross product is 75 is equal to 12x. And that's going to give us a decimal. They love to do that. Uh-oh. Can I go back? Somehow I made it big. Oh. Okay. I guess I can live with that. Put it back. It's a little too small now, but we'll make it work. Alright, so we have to do 75 divided by 12 to find out what x is. Okay, so go up here to our handy calculator. 75 divided by 12 is 6.25. So x equals 6.25 inches. That's what this side is, 6.25 inches. It's much smaller than the 15 inches. It's a smaller parallelogram. Okay, let's try another one using indirect measurement. Alright, now this one's kind of neat because it helps us to find out something cool. Say you have a cool palm tree, and I'm not going to draw a good picture of it, and you have a guy standing here, and the sun is shining, and the palm tree casts this shadow on the ground, and you cast a shadow on the ground. Basically what we have here is we have a triangle and a similar triangle, because the sun is over here, it's shining the same. It's so far away that it shines virtually the same on everybody. Okay, and as long as you're standing in the same time zone, you're standing next to each other, you're going to cast a shadow that's pretty similar. So you're basically creating a triangle. And you don't know how tall a tree is. This is the cool thing, but you can find out if you know how tall you are. Say you are 6 feet tall, so you got this little triangle. This is you're 6 feet tall, and you're casting a 3-foot shadow. And the big palm tree has a similar shadow, similar triangle. It's casting a 15-foot shadow. But we don't know how tall the palm tree is. And so we can use our corresponding lengths. We've got, this is our x over this corresponding. So x over 6 should be equal to 15 over 3. So this over this should be equal to this over this. Hopefully that makes sense. And again, you can use cross products, or you could actually just notice that you could go 6 divided by 2 is 3, so x divided by 2 is 15, so x has to be 30. Or you could go the other direction, 3 times 2 is 6, so 15 times 2 is 30. Or using the kind of the standard, it never goes away cross products, 6 times 15 is equal to 3 times x. And 6 times 15, well, 2 times 15 is 30, so this would be 90. And then divide by 3. 90 divided by 3 is 30. So the height of the tree, the palm tree, is 30 feet. And that's pretty cool. So you can find, just by using a shadow and your own height, you could find how tall the school is, or the flagpole, or all kinds of things. You just got to be able to measure the length of your shadow, or use some other indirect measurement, some way to find out something. This is kind of a neat thing, because you can't always tell how tall something is. You can use algebra to find out that answer. We got one more thing we've got to show you about area. So we've got using proportions to find area. So finding area. And we're going to have, okay, so there's this big area, and it's a swimming pool, and then there's a smaller but similar area that is a tennis court. The swimming pool is similar to the tennis court in shape. What is the area of the pool? Well, we know that this side of the pool happens to be 18 yards. And we know that this side, the similar corresponding side of the tennis court, is 10 yards. And the length of the tennis court, oh, we don't know the length, but we know the area, is 200 yards squared. Okay, so we're going to use the idea that we've been kind of flirting around with, the area of the court over the area of the pool is going to be equal to the width of the court, this is this 10, over the width of the pool. This is court and pool, and remember we have to square it because area is squared. This is from the last lesson. Well, we can just put in 10 over 18 squared. We might want to simplify that, because we could just say 10/18 is the same as 5/9. Square that is 25/81. And then we know that this area of the court is 200. So we could rewrite this equation using an easier color. That 200 is the area of the court over area of the pool. We'll call that P. Actually, we should just call it A because that's an area. I like to use it. Is the same as 25 over 81. And now we're going to have to do this 200 times 81 divided by 25 thing. And this is probably a calculator exercise. So you just, you multiply 200 times 81 and divide by 25. Clear it out. There's 200 times 81 divided by 25 is 648. So then this area is 628 yards squared, and that's the area of the pool. It's not 628, the calculator said 648. Sorry. Let's go back. 648, that's the one. Let's go back to make sure, because I think I remembered it wrong. Yeah, 648. So this is a little more complicated, but you can do it. Good luck.